Segways are overrated.
Yeah, we don't need a segways. But wait.
Hi, and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Tom Nardi, managing editor.
This is episode 157. Today we'll be talking AirTags and security, warped 3D printing, suturing grapes with a DIY robot arm, and the Wizard's calculator. Well, we didn't have super much for news this week, but I wanted to touch on this article that got forwarded to us by basically everyone and their mother. Bionic Eyes Go Dark was our write-up of it. It was an article in IEEE Spectrum about a company that made bionic eyes, basically, made artificial retinas and the software and DSP processing and all that goes along with it, that is basically a startup and is basically going out of business. And so people who were essentially completely blind, who had been able to see kind of limited grayscale, small number of pixels, but to be able to see it all, are all of a sudden left without any updates, any chance of getting their device fixed if it goes wrong. Just an absolute nightmare scenario for them.
Yeah, it's really heartbreaking if you read the linked story. I mean, it talks about people just walking down the street and then they heard a little noise and then their eyes stopped working. Like this is the nightmare future we were warned about.
Yeah, this is the part of like Blade Runner that, you didn't think about. Like in the future, they always have these bionic things and everybody's all cyborgs, but you don't think about what happens when the company making your cyborg parts stops supporting it or whatever. The reporting on this is just fantastic. They actually went and interviewed a lot of the people who had the devices implanted and so on. It was a really great write-up. It makes me wonder if, since the company's abandoning the product anyway, if they couldn't open source it. But I think that's a super long shot. I don't think... it's one of these companies that looks like they want to hold on to their intellectual property as tight as they can and not let anyone use it for anything, even though they're probably not going to use it.
Right, especially because, and some of the people said that in the article, like, it worked fantastic. They said it's a great technology. It's just, unfortunately, the company that is in charge of it sucks. So they're probably trying to, sell it to somebody else. So
that actually is quasi-hopeful, right? If they sell it to someone else who has a better business model.
It kind of reminded me of the story we did, a couple of years ago, I guess, about the people in the iron lungs. You still have those handful of people using these things, but nobody makes the parts for them, and they're kind of left just hoping that today is the day their machine doesn't break.
Right.
But, I mean, at least with an iron lung, it's the kind of thing that you could, in theory, get, like, the local hackerspace to work on for you. I mean, this thing is an implant in your eye. It's a little bit beyond, as much as I hate to admit it, a little bit beyond our abilities, I think, right now.
I did say maybe people could hack on this, and someone in the comments took me to task and was like, oh, that'll be fun. We'll hack on something that's implanted in your eye. And I'm like...
Well, not that part.
Yeah, there is that. I mean, it's certainly high risk, right? But you hack on the part that's outside of the people's eyes.
Right,
you don't actually have to go in with your JTAG debugger into the person's eye. You work on the part outside. Anyway, I don't think that's very likely. I think it's probably ends up just being a weird, sad, futuristic story that's, now the recent past.
This is a journey into sound.
What's that sound?
What's that sound?
All right, it's time for What's That Sound? Last week, Christina Panos was special guest on the podcast, so I did a keyboard sound. Who can tell one clacky keyboard from another?
I'm worried there's a whole subset of people that can tell clacky keyboards from another.
The answer is Christina Panos could. I don't know if I could have, frankly, and I type on these every day. The correct answer is that they were Cherry MX Blue key switches, but both of the samples I found of these on the internet were people who were just like hammering away at them. I don't know, man. I type with a gentle touch. I don't know who these people are.
I mean, it's impressive you can pick it up, though. I think the noise changes a lot based on all kinds of, what the plate is and everything.
But we had a number of correct answers, actually. So, no worries. We had a few people thinking that they were Browns, which is a fairly reasonable guess. I mean, Browns are kind of the next door switches to these. So I kind of buy it. A couple people said that they were the buckling spring ones.
Oh.
Hold on, I'm going to get a keyboard. Can I do this?
There you go.
This is what buckling springs sound like, people. You hear there's kind of that little...
yeah.
There's a kind of a little... I don't know what, a little springy ringingness afterwards. Anyway.
Oh, you went easy on them, giving them the blues, too. I mean, those are arguably like the most popular, too, right?
That's right. I mean, I'm not a total jerk. What am I going to do?
You get those are real rare ones.
Some of our guesses, of course, did go out there. Calculus decided that they were MX Frankenswitch's Holy Pandas, which are these... there's a whole, like, I'm not as into key switches as some people, but there are people who like one profile, but then they like another, like, housing or something, or this is smoother, or different springs. And they like make these like keyboard switch mashups that are like half of this and half of the other.
I got one of those little samplers with the 9 keys on it, so you can push them and decide which one you...
Dude, I really want to get one of those someday. But I'm a simple man. I'm willing to take any old good mechanical key switch and type on it. I typed on browns for a long time. I typed on reds for a while. I'm typing on blues now. You know, that was an audio sample from my old Model M keyboard. But like, as long as it's a good keyboard, I don't really care all that much. Anyway, 8 people got the answer right. I will have to roll an 8-sided die. And the winner is 8, which is Edgar. Congratulations, Edgar. Cherry MX Blues for the win.
There you go.
I'll get in touch with you and get a t-shirt out to you soon. And those of you who didn't win, check in next week. I'll have a non-keyboard sound for you.
I was going to say, we're just going to walk through the whole MX product line.
So I'd like to start off the hacks with Fabian Bräunlein's No Privacy cloning the AirTag. And this is actually an interesting hack, but also basically a great look at the security of the AirTag system. And this is Apple's system to make these little tags that send out Bluetooth BLE beacons to other products in their neighborhood. They pass the encoded ID number and its location off to the iCloud, and then you can query this and decode it if you happen to know the device's ID. It's actually a really clever system in a way. It uses public key encryption to keep the location secure, and it has a rolling identifier system so nobody can track you by your Bluetooth LE ping beacons. But it's already been abused by a number of people who are hiding AirTags on people to basically use them as surveillance device. They're trying to use them to trail people by hiding AirTags on them. Apple's responses to give people privacy have been kind of mixed. They have an app that runs on iPhones and only on iPhones that'll tell you if a foreign AirTag is following you around for a little while. That is great. It gives iPhone people security, kinda, but it's really crappy for everybody else in the world. Fabian points this out in this write-up, actually. One of his main contributions here is finding a way to defeat even Apple's "there's an AirTag near you" procedure. He sets up beforehand about 2,000 of these public key encryption pairs, both on the tag and on a computer that he controls. Instead of using an actual tag, he uses an ESP32 that's spoofing a tag, and then it just rolls through these 2,000 IDs. So you can hide it on someone, but it changes its ID 2,000 times, so every minute for the next few days. And so even if they have the iPhone app that's supposed to detect someone tracking you, it completely defeats that. Reading through his complete tearing apart of all of Apple's newest security guarantees here, you can kind of like hear his disdain for what Apple's done here. Like, he's extremely professional about this, and just ends up saying Apple should have considered people using non-AirTags in their AirTag system as a security vector. And they didn't consider that basically most of their security design relies on you using an actual AirTag and not spoofing an AirTag with an ESP32 and then wreaking havoc.
Yeah, it breaks all of their carefully constructed rules if you just bring your own hardware to the party, and given that creating BLE tags is not particularly hard to do,
Trivially easy.
It really seems like this is something they should have considered. He talks about how the main thing is Apple says you can't have anybody hide a tag on you because it'll beep. Well, my ESP32 doesn't have a little speaker, so we don't have to worry about that. But he even points out, and I checked on eBay, and he's right. There's a little market of modified AirTags where people just yank the speakers out of them, and now you have a silent tracker. And it's interesting. I don't know if it's true or not, but they're marketed for tracking your pets. Because you don't want to put this little beeping thing around Fluffy's neck, but they could just as easily be used to track your girlfriend, by the same logic. So it's kind of weird. I think it's one of the things where they sell it as one thing and it's kind of like a wink, wink. But like he said, if his ESP32 doesn't have a speaker in the first place, so either you're yanking the speaker out of a real AirTag or you just don't have one to begin with. And then his idea of rotating through the keys is brilliant. I mean, it's never going to see you because you never have the same key. Not to undermine what he's done here, but this is not rocket science, really. I mean, these are pretty glaring flaws in the system.
Yeah, but you have to have a hacker mindset to see these. These are a lot of the flaws in old school Bluetooth, classic Bluetooth were like this. They're if you fuzz this, you can break it. And then you talk to the Bluetooth engineers. I got this from Jiska Claessens, who did a lot of research on Bluetooth. And she's you talk to them and you tell them, I did this and it breaks your device. It hard resets it. And they're but why would you do that? That's not in the spec.
Yeah,
that's not in the engineering manual. You can't do that. And, that's the point here, I think, is that the Apple people, for how that's possible, I don't know, didn't bring a hacker mindset to security on this and didn't think, what if people start speaking random Bluetooth to these things?
Right. Well, I think a lot of it's an Apple, walled garden mentality, right? If it wasn't made here, we don't worry about it. Their good little Apple users wouldn't dare bring their own hardware to the party.
I should talk about the AirGuard project, which is an open source Android app put out by the CMU lab here, security people, University of Darmstadt. They made essentially a better version of Apple's tracker tracking device for Android systems. And so they fixed that side of things up. And combining this with Fabian's work here, you kind of get this feeling that Apple just opened up Pandora's box here and was here, we're going to spring this on you, the world, and you have to figure out all of the societal ramifications. You have to figure out the security problems, and, all you people using Android devices, sucks to be you. Hopefully some beneficial group of hackers is going to solve your problem for you. On the other hand, you do have to think there is totally a use for these devices that don't beep and aren't traceable. Imagine you wanted to do this to secure your bicycle, right? You would want a beeper on there that reports where your bicycle is once it gets stolen and doesn't go beeping and doesn't tell the thief that there's a tracker on it, right?
Yeah.
So there's totally a number of situations where you actually want the silent tracker, but then there's all these situations where people don't want people to be tracking them. And this is really kind of a societal problem for which there is no technological solution.
Yeah, the ideal bike tracker is also the ideal spouse tracker,
Right.
And there is no way to fix that other than don't track your spouse.
Yeah.
Like you said, it's a societal thing. Just stop that. Just
stop doing illegal things, please.
Right.
Yeah.
But I mean, you can say that about a lot of tools are tools, right? It really depends on how you use it. I mean, we see that all the time.
Legislation will catch up eventually, you hope.
Oh yeah, one of these days.
But is that going to be 5 years? Is that going to be 10 years? I don't know.
No. In the meantime, Apple will be able to figure out where you are when your bionic eye turns off and you need help. So,
really interesting work here. I think it's a great dissection of the flaws in the AirTag security guarantees. And if you're at all interested in this and Fabien's older work where he manages to tunnel data over the AirTag network are both worth looking at. I thought that was one of the sweeter hacks I'd seen since Dan Kaminsky's old Aussie Man DNS data over DNS hack, which I just had to look up now because it dates back to 2004. Anyway, links for all this stuff you will find in the show notes.
Well, this one was particularly exciting to me when I saw it come into the tip line. It's something I've always been fascinated with, but thought it was one of those kind of technologies that was outside of the home gamer's budget. This one comes from DJ Jules, and it's his instructions on how to build a DIY hydrophone for far less than you would imagine. And if you're not familiar with the device, this is the kind of thing that they would have on a submarine to let you hear, Russian propellers and that kind of thing, and torpedoes rushing towards you. Broad strokes, it's an underwater microphone, right? But there's a lot more engineering that goes into that. You have to consider how sound propagates through the water and the materials you use, and Jules does an amazing job, partially because he spent 20 years in the Navy on submarines, so he knows a little bit about this kind of stuff, but he also went through like white papers that were released by the Navy, by NOAA. He just kind of compiled all the information that was available, cross-referenced that to what he could get his hands on as a civilian, and came up with something $50 maybe, all told. It's startlingly cheap for the technology in it, and the key is a cylindrical piezoelectric transducer, which right off the bat, I would have figured that was the kind of thing, where do you get these,
right.
where do you get these beautiful toys? And he actually found a company that sells these things, and they're made for underwater communication and scientific use and stuff. And even still, they're like $16 each. Like,
yeah.
I couldn't believe it. I thought there was a zero missing or something. I mean, he shows the picture. They come in this little cool box with it's wild what you can get on the internet for cheap. But once you got the transducer, he came up with his own amplifier board. He has his own fascination with audio devices, so he was able to adapt one of his existing designs over. From there, it's really just a matter of putting it in a acoustically transparent housing that can also be immersed in water. So he finds a casting resin that has the same specific gravity as water. He tested different ones and found out which one had the closest to water, and then that makes it so essentially the sound waves just pass right through it as if it wasn't there. He's got a video that has some demos, and it's what underwater sounds like. You can hear
That's
bubbles,
awesome.
you can hear hissing and stuff. This is not the kind of thing that everybody needs, but if you are interested in, fringe audio and maybe if you want to record, biologicals, I mean, I know some people, they use them for picking up whales and that kind of stuff. It's a really cool project. It's surprisingly approachable, and I may have to build some hydrophones of my own after seeing this project.
Oh, I think you definitely do. Yeah, his last project that we covered was also a microphone hack, but one for use in the air, you can talk to it microphone. I totally love that you picked up on the urethane resin casting thing, because the bit with the having it be the same density as water, really, the physics totally makes sense, but I didn't expect that. And that was the part of this that that was the thing I learned about hydrophones from reading this write-up, right?
That's that Navy experience, right?
That was the bit. Yeah.
Because the hacker approach was just dump it in some kind of rubber, but the waterproofing is only half the battle,
It's not about waterproofing it. It's about not making it less sensitive. So, good for him.
And he even mentions that the specific gravity of freshwater and seawater is different, and this one is a little bit closer to seawater. So you could even say, if you plan on using it in freshwater, you might actually want to use a different resin mix, because it's a
tweak
few
the
percent
urethane
different.
Mix.
Yeah.
Oh, funny.
Yeah, he's a good dude too. He emailed me afterwards, and he was it was almost like an underhanded compliment, because he was like, sometimes Hackaday posts are just copy and paste, but I can see you really put a lot of effort into it, and I appreciate it. And I was like, okay, thank you. At least I am not the copy and paster, but still.
Next up, Stefan of CNC Kitchen has a YouTube video, Bend Your Vase Mode Prints by Hacking the G-Code. I love this because this is something that's kind of going around in the 3D printing world at the moment, is people who are starting to do their own post-processing. Like Thomas Sanladerer put out a video discussing a G-code modification and tweaking and generation suite, full control G-code, and you should check that out too. But basically, I love that people are taking 3D printers and stepping away from kind of the slicers that do the obvious thing, which is to make a whole bunch of horizontal slices and then feed that to the printer and tell it to draw the perimeters and do some infill and make a model that way. People are starting to tweak the G-code themselves again to make the 3D printer move actually in 3 dimensions. Like if you think about the way a 3D printer works, it kind of lays down one 2D layer and then it goes up, and then it lays down another 2D layer and then it goes up. Is that really ever moving in 3D? Not really. It's kind of 2D and then up, and then 2D and then up. It's never really moving in 3D. And we've seen a bunch of hacks recently, including some multi-axis machines, this one about full control G-code, and now this by Stefan of CNC Kitchen, which actually move the print head, move the extruder head in 3 dimensions to make fun shapes. And they're doing it all themselves by playing around with the G-code, because none of the standard slicers will do this for you. The cool gimmick here is that Stefan's doing it in a particularly simple way. He takes an already sliced model, and then he kind of puts a bendy spline into it and distorts the G-code. So whereas before some of the layers would be horizontal, now they're angled up and angled up and angled up a little more and a little more. And eventually you can make, what was a column into a banana or something like that. If you think about it, the only thing you really have to do is you have to take these planes and you have to tilt them. But then you also have to make the edge on the outside where, the 2 planes are furthest apart from each other. You have to extrude a little more. And on the inside of the radius where they're pressed toward each other, you have to extrude a little bit less. And that essentially is all his Python code does. It just takes these layers, warps them that way. And what it does is it lets you make bent prints out of already sliced objects. I think it's really charming.
I think this is really cool, and this might be a hot take. We'll see. But I think you could say that, traditional slicing is very nearly a solved problem at this point. We've kind of plateaued. You look at like the changes that are coming out in like Prusa Slicer, and you're in that, just kind of tweak and polish phase. I mean, we pretty much know what to do. Like we know how you do things, like you said, parallel to the bed. This is like the new frontier, right? Like we've kind of solved all those problems, and now we're looking at ways to push the machines. And like it's cool that the head, the print head doesn't actually have to be angled for this one.
Right.
I mean, so that's nice. It's not like you need to have some kind of printer that can only do this. Not that it was easy, because he talks in the write up about. He actually started, I think, on a Prusa, and it didn't really work out because you have all these things next to the nozzle. You got the fan, you got the bed sensor, and they start hitting. When you start trying to print angled objects, they started to hit. So he had to switch over to a tool changing setup that had more space around it. But other than that, it was, it is a regular hot end. And it's just, like you said, moving the machine in a full 3 dimensions instead of that 2D step at a time. Is this something you could use for all designs? Probably not, but it's definitely cool to see traditional machines being put into new applications, and who knows, this kind of stuff. I think what was the goal, like rolling marbles or something with these things.
He took tubes and made them into bendy marble drop things.
Yeah, this was not exactly a life or death project, but you never know. Like this could be the start of something major. I mean, being able to make different curved tubes, bespoke is pretty cool. So it's just a matter of finding, the applications for them. And, and who knows, you could maybe do more models. There's something to be said for, avoiding traditional supports and that kind of stuff. If you can, approach the print from like a different angle, it's just very exciting. It's exciting to see that there are still stones left unturned, right? Like it's not just hit the button and print. There is still something. There's still something out there to be discovered.
Yeah, I think this whole topic of kind of non-planar 3D printing is still hot. I remember a long time ago now, maybe 2016, I'll find some links for y'all. Moritz Walter wrote up a piece for us where he did some non-planar 3D printing experiments. And that write-up on Hackaday is just fantastic. He was following this research paper, which actually Stefan in this video cites, that kind of was influential in starting this whole new wave of thinking about non-planar 3D printing off. So it's all kind of one thing. Those of you who haven't been in the 3D printing game since its very beginning might not know about what the slicing tool chain used to look like back in like 2009, but it was ugly. And a lot of it was what I was using back then was this SkyneForge, which was kind of a loose set of Python scripts. And you would run like all of them, and there were like 20 of them, and they all had, outrageous numbers of options. Configuring it was just a horrible mess. But what was neat about these is that, like what Stefan's doing here and like what Full Control G-Code does, each one was kind of operating on the G-code after each other. And some of them interoperated, but others didn't. And you can still find this code out there too. So if you are inspired and want to tweak around with some G-code modification hacks, some of that code base might actually be worth looking at again. Because some of those ideas, basically all of the ideas out of SkyneForge got merged into any of the modern slicers that it was kind of the granddaddy of. Still, if you go back and look at this kind of piecemeal, one tweak at a time approach to things, there may be something in there to help guide you on your way toward forging your own G-code with your own 2 fingers. 10 fingers? How many fingers do people have these days?
Well, speaking of teaching old machines new tricks, I was really into Andrew's project about bringing I2C to a 70s era Casio FX502 calculator. A little bit of a trick here. The calculator itself is not speaking I2C, but no. There's a STM32 microcontroller in the mix. Andrew still had to figure out the protocol that the Casio used to talk to its original little peripherals. I guess there was printers and stuff that you could hook up to it. So he figured out the protocol it used to talk to those, trained the STM32 to talk that, and then from there was able to adapt it to I2C. In the video, he's got all kinds of weird gadgets attached to a Casio. He's got like the OLED display. He's got an SD card, all kinds of stuff. Push buttons. What could you use this for? I have no idea. I just really like the visual of all this stuff hooked up and working to this old Casio. Potentially, I know he does talk about using the SD card to actually store some stuff on there, so I suppose that's half practical. More likely you would just use a more modern calculator, than doing this. But it's still cool to see one of these old protocols hacked. And then there's some interesting details on the protocol, too. It's pretty weird. It talks about, like, its inverted data logic. So, like, 0 volts is a 1, and 3 volts is 0, which it seems like just being obtuse for no reason, right?
Yeah.
So it's just, it's a cool story about poking around a pretty rare protocol, figuring out how it works, and bending it to your will, which I think that's kind of what the whole site is about now.
Hackaday.
Yeah. We should see if we can find like one of these every day and write about it.
What I really loved about this is he starts off the video by talking about the calculator cradle, which is the thing that interfaced with a cassette tape drive and did the storage on that. And that, of course, uses 2400 baud beepy boopy tones, which...
Is that the technical term?
The Kansas City standard is the technical term. But
okay.
It's beepy boopy tones at 2400 baud. And that's lovely. Like, there are a ton of times where, transmitting data over a simple audio link would be a useful hack to have up your sleeve. And so I always think that those kind of libraries are useful to see ported to modern microcontrollers. So I'm always happy to see kind of old modem hacks made new. But then nobody has this cradle. This cradle's a pain in the butt. And so he has to bypass it. And then that's the rest of the hack that you were talking about. It's probably the world's worst brain to use as a data logger because it's like slower than the microcontroller that's doing the interfacing.
Yeah. At the end of the day, why would you do it on a 1970s Casio calculator when you have a perfectly good microcontroller in the mix? But I suppose that's hardly the point.
I have seen the most amazing robot arm hack of the year, I think. This is Zhi Hui Jun's Dummy the Robot Arm is Not So Dumb. This is an insane robotics arm project. He uses stepper motors with some closed loop drivers, so they kind of operate as servos. He manages to get some harmonic drive gear reducers used for like $100 each, which sounds like a lot of money if you have to buy 6 of these for the 6 degrees of freedom in that arm, but normally they're like $1,000 each. So I don't know. He lives in China, so wherever his junk store is, it's better than mine. I'm super jealous. Sure. He spends a lot of time on the design of this thing. A lot of the parts are custom aluminum anodized, and he gets them machined by a friend of his. So as he says in the video, it's good to have friends who are superb machinists. I believe that. Zhi Hui, he's the guy who did that self-balancing bicycle hack that we must have featured, I don't know, maybe a year ago now. Zhi Hui seems to be superb with the software side of things, and that's where this robot arm really shines. So he's got a precise and backlash-free small tabletop 6 degree of freedom robot arm. And he's like, how can I control this thing? And that's where he just has a field day. He does this augmented reality take on it on a cell phone where he can like click around and move it. That's kind of fun. The coolest one that I thought he did was a controller where he has a stereo camera on his desk and he can use his hand to move through positions that he wants the robot arm to be in. And he's made a little gripper attachment with a couple buttons on it. And, one end has an infrared LED that the cameras can see. And that kind of says where the business end of the robot arm needs to go. But then the buttons are scavenged from a PS5, and those are the ones that have these crazy like force feedback servos in the buttons. And so then he builds a force feedback gripper arm for the robot so he can actually feel force feedback when he gets tactile feedback from the controller when he's trying to grab onto things with the robot arm's gripper. That's just an astounding level of sophistication here. And he has this video that's, 15 minutes long, and he is just going full out explaining all of the crazy things that he did. I didn't cover them all. He finishes this up with him suturing up a busted grape that he bought using the robot and this controller. And that tells you a little bit about what kind of fine control he has here, right? Like he's able to actually take a needle and thread and like sew up a grape. He says at the end, why would you ever do this? Well, and he makes up all the reasons you would build the world's most amazing robot arm and software suite for yourself. But I think that speaks for itself.
Yeah, the whole time you were talking about it, I was like, I hope he brings up the grape. I hope he brings up the grape.
Dude.
the grape is so cool. But that's the kind of thing they do. I mean, I've seen like surgeons practice on, stitching together grapes and stuff like that.
Exactly.
So there is like a real world parallel to that. There's just so much going on here. Even in the write-up, Dave Roundtree says, just watch the video because, you can't really. There's some projects that you just need to watch it all because so much happens so quick. I'm always kind of jealous isn't the right word, but I wish
I hear you.
I wish I knew what to do with a robot arm. Like they're so cool, and all my grapes are intact. I don't need to sew any of them.
Damn it!
But like it's just such fantastic engineering and the capability. Like I said, the force feedback it's just wild. Not that you need a reason to build these things, but I'd love it if there was some like clear reason that I could convince myself to have one of these things in my own collection of tools.
This is such an incredibly rich video. And the other thing that's worth noting here is that a lot of it, not all of the software, but a whole heck of a lot of it is open source, and it's up on his GitHub along with the designs and everything else. You'd have to really want to make this. This is a real commitment of a project to remake. I mean, you have to find the same harmonic drives as he did, et cetera, et cetera. So I don't know that this is one that you're going to want to rebuild, but this is one that you're definitely, if you like any of kind of these subparts of the project, and there's just so many subparts to like, that's where you could go check out his GitHub and see how he did it. And that is probably what I think is worth it in this one.
Well, to segue from a piece of hardware that none of us could justify having on our own to something that we could actually use, I was really into Steve Ganaud's Deck-in-a-Box tool, which is a web-based service, I guess, for lack of a better word, that lets you design boxes, compartmentalized little boxes. I think the original goal was for holding like little pieces for board games and that kind of stuff. But of course, it could be anything else. It could be components, could be screws, could be whatever. A lot of the boxes are like paper craft, which is really cool. You fold them and build them up. But there's also a section for 3D printed boxes, which is frankly a little more interesting to me, because it's this whole web-based, customizable, parametric tool to generate files that you can print out. The real cool thing is that all of that stuff is kind of its own project on the back end. The Deck-in-a-Box site is the friendly, this is what it does example, but all that technology, the libraries and all that stuff is equally, well documented and ready for your own project. I'm a big fan of OpenSCAD. We talk about that a lot, and it's good. It's good in its own way, but it has some deficiencies. And I'm certainly not against other code-based CAD projects out there that rethink the way it works, especially the parametric side of it and being able to customize things through the web. I think there's actually a lot of promise there, because it allows people who don't necessarily have any CAD experience to make custom designs just with sliders and little radio tick boxes and stuff. So, you can do a lot of that heavy lifting. You got to put the effort into the design to, put that kind of parametric flexibility into it. But it does open up a lot of possibilities for these bespoke 3D printed things that you don't need to have first-hand CAD knowledge to make use of.
We usually do 3 quick hacks. I'm doing 5. I'll have to do them 5/3 times normal speed or something. 133. I just couldn't stop myself. There were so many good hacks, and this isn't even complete list of them. You are just going to have to go back and read Hackaday this week if you already haven't. I'll start off with Whiskey Tango Hotel's classic multimeter tells you if your Wi-Fi is working, takes a Simpson 260 ohm meter, voltage meter, and turns it into a ping meter for his internet. I think he puts an ESP8266 in there. It PWMs a voltage out. The meter isn't hurt, and it gives it a neat task to do sitting on his desk. Low-tech obsession, minimalistic doorbell doesn't need an internet connection or even power. This is your annual reminder that stepper motors are not just motors. Every motor is also a generator. You turn the stepper motor and it rings a bell. The really cool part is that the electromagnet on the other end that does the bell ringing is the head from an old busted hard drive. Rahel Zahir Ali, super simple camera slider with a neat twist. This is a no microcontroller camera slider that keeps pointed at an object in the center, for which you normally need some kind of complicated coordinated motion pivoting sliding thing. The gimmick here is that it slides on 2 rails, but there's also a third rod that controls the pivot, and so you can slant it relative to the rails and it pushes a little pivoting head on a skate bearing. This is an awesome 3D printed clever mechanism. Next up, a video series, Sean Heimel for DigiKey, FPGA starter videos to help soften that learning curve. Sean steps through in like 12 videos the entire open FPGA toolchain on the Lattice Ice Stick Ice 40 series of FPGAs. From start to finish, there's so much good content here. It ends with a RISC-V soft core flashed into it and how to integrate that into your projects. It uses the open source APIO and just a lot of the projects coming out of the FPGA Wars team's open source development effort. It's a fantastic introduction to the state of the art in open source FPGA programming. And last but not least, the crazy clock maker himself, Egkarat Singh Khalsi. Unique clock is all hands, no dial. Acrobato, it's called. It actually moves around on the desk. It's like two hands of the clock. And if you think about it, one of them is always lower than the other. That one manages to be attached to these like servo motors that grab onto it, power it, and pivot it. It is insane. You're just going to have to look at that one.
Well, after that shocking abuse of authority, I'm going to pick just 3 hacks as we decided.
You're a man of restraint.
My first quick hack is Winamp Reborn with the Adafruit Pi portal. I think readers and or listeners of a certain age will recognize the Winamp default skin as a milestone in the MP3 revolution. This is a project that recreates the look, if not the functionality, of Winamp on the Adafruit Pi portal. What I mean by that is it looks the part, it has the little scrolling track info, and it has all the equalizers and that stuff, but it's all kind of just for show, and you just tap the screen to play and pause your songs. Doesn't mean it's not a cool little display for the desk, though, and the fact that it actually supports the original Winamp skins means you can make it look just like the original player from your heady MP3 days. Next up is high-powered laser salvaged from headlights. We actually did an article about that. I think Lou and Day explained like the science behind laser headlights, and this is the practical end of it. Diode gone wild, got some laser headlights. I think he says from a Range Rover or something like that. Tears them all apart. There's a lot. There's a lot of parts in laser headlights, but if you get right down to the core of it, there is a little laser diode that's not completely unlike what you would see in like a laser pointer. Here it gets liberated and mated up with some optics to burn things. Frankly, what else you gonna do with a little blue laser, right? It's not a great source of little blue lasers. You can go on eBay and get one of them without having to take apart a headlight. But it is cool to see how it all works. You know, I know personally, I'm waiting for more cars to have these so we can start pulling them out of the junkyard and see what kind of interesting projects we can come up with. And then lastly is winding your own small coils from John Audio Tech. The trick here isn't necessarily to winding the coil. That's kind of just wrapping wire around a cylinder. But he goes into the technique to estimate how long the wire needs to be and, you know, how to make your own inductors, which is not something that is necessarily something we do day to day, but if you ever need a custom one, it's going to be a lot easier to make your own than trying to find one online and wait for it to get shipped out to you.
All right, that brings us to the can't miss hacks. These are long-form original content articles written by Hackaday's glorious writing team. I'm going to start off with Dan Maloney this week, continuing his Big Chemistry series. This one is Big Chemistry from Gasoline to Wintergreen. This is such a crazy idea. We were talking about this, and he was like, I guess the idea came to him to write the story from a kid overdosing on wintergreen, which is actually pretty tragic. Don't eat too much wintergreen because it is actually poisonous in large doses. But then he was like, how can wintergreen be poisonous? And he started digging into the chemistry behind it. And so the artificial wintergreen flavor is methyl salicylate, and that's made from methanol and salicylic acid. And then he's like, wow, where do you get that from? Methanol, that's creepy. You know, you can burn that. And salicylic acid, where do you get that? And then he starts digging into that. And of course, you can get that also from petrochemicals. It's made by combining phenol with high pressure carbon dioxide. And then where do you get phenol from? And the answer is also from petrochemicals. And so kind of tracing back the synthesis of wintergreen, which is a bizarre way to start, it turns out to be gas all the way down. Like it's petrochemicals here, petrochemicals there, the way we make it. And it's a really interesting take on kind of what modern big chemistry is. And, somewhere along the way, it splits off into aspirin. Salicylic acid, I guess, is what you make aspirin out of. And all of that is also made from phenol as a feedstock. And so, it's just weird to think of aspirin also as being something that comes out of a wellhead. Not directly, of course.
Right.
And, there's a lot of this, nearly every stage along the way is one of those classic chemistry things where it's under high temperature and pressure. None of these are kind of reactions you're going to be doing at home, except for maybe the last step of the wintergreen synthesis.
Like you said, every step of the way, you'll recognize these things, this, benzene and propylene, and then you'll know all of these things, but you probably never thought about eating them, right? It's amazing.
Exactly.
It is amazing to see, how it all comes together. And at the very end, Dan even says, we're almost there. Remember, we're trying to make wintergreen, because there were so many steps that you perhaps forgot in the process what we actually were trying to do in the beginning. Because it does go down these crazy, twisty roads of, like you said, who would have thought? All these things are related. I've said it before. I'll say it again. I love these posts that Dan does. He's kind of going all in now on just the weird and wonderful ways of things that we take for granted. How do we get to these things? He's talking about fertilizers and now flavoring. It's kind of... it's humbling, really, right? To see how much technology goes into the simplest of things. It's also a little illuminating to think that the flavoring that we're using may have started, like you said, out of a wellhead. But at least I'm all the better for knowing it, right? At least I know what even if I don't like how it was created, at least I know it now.
Yeah, and I think part of what this suggests is kind of just how cheap these petrochemical precursors are. If it were easier to make aspirin out of tree bark from the willow tree, we'd be doing that. The point here is that we've already got the salicylic acid process ramped up because, we need it for other things. We might as well divert some of that into making aspirin. And then it's all the phenol, there's a point where it splits. If it makes a left turn, it turns into polypropylene. And if it takes a right turn, it turns into something that then becomes the feedstock for making aspirin, which then can take a turn and become wintergreen. I think it definitely points out that there's some kind of weird economics here at play that make it the easiest way to get this stuff.
Well, I think it does show that we have a reliance on petrochemicals is kind of shocking. We think of it kind of like surface level stuff, like just powering cars, but we really do use it on every facet of our life. So it's gonna be very hard to break that addiction.
All this stuff that contains hydrogen and carbon, you can make it out of hydrocarbons.
Well, my pick this week is Inputs of Interest. Canadian MCM 70 was kind of like the first Cyberdeck. If you don't know, the Inputs of Interest series comes from Christina Panos. I think that she cheated on this one a little bit. I don't think this is an input device at all. So I think it is ineligible for the series, but I will allow it because it is really cool. And I did like her angle of saying it's sort of like this prototype Cyberdeck thing. I mean, it looks like a movie prop. It's actually a very, very early 70s, we would call it, you'd call it a laptop-y kind of thing now, but, with its little one line, I think of 32 character plasma screen and very limited capabilities, it's hard to imagine you doing much general purpose computing on it. But it's got, all the trappings of a good 70s computer. It's got not one, but two cassette tapes.
Yeah.
For storing your data. It's the beigest of beige boxes. It's got a big keyboard with a almost comically large space bar, which I'm not really sure what the logic was with that. I think it's really cool. Like the legends on the keyboard are wild too. It definitely built for purpose. And in 1974, it would apparently cost you just shy of $10,000 US for this 800 kilohertz, kids, not megahertz. It's a 800 kilohertz processor. So it is amazing to see just, how far we've come. And I like to think that we've seen a lot of old weirdo computers on Hackaday. And I know I have never seen this one before, so I thought that was really fascinating that this is, I always kind of thought like Tandy Model 100 or whatever was one of like the first portable, computers, but this is, a decade before that, right? It's like 74, so it is really cool to see kind of the origins of something now that we all take for granted, right? We all got portable computers in our pockets.
I'll defend Christina on this one. I can tell you how this got into inputs of interest, and that is that crazy keyboard that you see on there. Because this machine had APL inside it running in its ROM, and so it's meant to be programmed in this ancient and bizarre programming language, which actually used these runes to like mean things. Like it looks like it's a squiggly something to you, but that actually is the command in APL for like a for loop. And like all of those things that are on that crazy keyboard actually mean something in the APL programming language. And I think if you want to know why this computer didn't go anywhere, I think that's probably part of it. But what's really cool about it to me is that it's got like that one line red plasma display. And that's really awesome. Like this is kind of the portable computer in a way. And that is a really interesting paradigm at the time that like didn't go anywhere. I think this is like a dinosaur that didn't evolve into anything else that we have around today. And that alone is worth having a look at it, right? Like this, I guess you bring up the Tandy Model 100 or 100 or whatever that
Something
was.
Something like that, right?
That did have like a little 4-line LCD screen on it and was kind of this like portable. And that may be the successor of this one. So maybe it isn't a totally dead dinosaur. But
to modern eyes, the more I look at it, if I showed my kid this, she would probably say it's a calculator. Right. It has more in common with like a big old school desk calculator, especially that one line.
Yeah, but with so many keys?
Right.
Like,
well,
is it a typewriter?
Yeah. Well, she'll probably look at the runes and say it does magic too. This is some kind of a calculator that they use at Hogwarts.
Wizard's calculator. Apparently, you were able to get it with the cassette bays were optional, and you could get it with one cassette and a modem, like one of those like acoustic coupler, plug your phones into it modems as well as an option.
So that'd be wild if it had an acoustic coupler. Would the handset of the phone have been sitting plugged where the cassette
cassettes are? Yeah,
you just got to look under the handset to see the screen.
So then the thing becomes like a one-line remote terminal in 1974. I mean, come on now.
Yeah, living life one line at a time.
Respect. That about wraps it up for this week's Hackaday podcast. If you'd like to reach out, you can send us an email, editor@hackaday.com. Of course, the show notes are up at hackaday/podcast. And if you see anything cool or you do anything cool, be sure to write us, tips@hackaday.com. And until next week,
keep on hacking.
Kids these days and their 10 fingers.
Yeah, with their fingers.
That's for suckers.
Very good.
Let's do it. Okay, here goes nothing.
I don't have anything. I'm just going to go into this one.
Salicylate. That is that. That's a wrap.